Every day, cars are getting smarter and more connected. Personally, I think that's a great thing. I've always been super interested in autonomous and automotive tech. So, for that reason, I decided to take matters into my own hands and hack my car in a project that I call Cruisin. The goal of Cruisin is to bring smart features to my regular car in the form of an advanced driver assistance system. It relies on computer vision code that I wrote and integrates with the car's existing systems. So, for those who are interested, I wrote the whole multi-threaded program in C++ and used Python earlier on for experiments, camera calibration, things like that. So let's quickly go over the vision aspect. On the windshield of my car, I attach this suction-cupped USB camera that supplies frames to my computer. Those frames are given to a couple different threads. So one which is detecting cars, trucks, pedestrians, and bikes using a single-shot detector neural network. The second task is even more challenging, which is mapping the trajectory of the car. This is called visual odometry or ego motion, which is an aspect of SLAM. And there's quite a bit of math involved, but the general idea is that I take consecutive frames and trace how pixels are moving in the image as the car moves. So the lines that you see here that are traced out indicate the general direction of camera movement. And with some math, I use these to estimate the 3D rotation matrix and translation vector between camera frames. There are some other tricks that I had to work on to suppress noise and to make sure the algorithm doesn't get confused by other things that are moving in the scene, but that's the general idea. The only issue is that the ego motion algorithm doesn't know how far it moves between each frame. It pretty much only knows its rotation and translation up to a unit step. So to have accurate mapping, we need to multiply the motion estimate by a scaling factor. To determine this multiplier, you could use an additional sensor, like a GPS or IMU, but to me it made more sense to just use the sensors that are already in my car. If you don't know much about how the computers in your car communicate, they all talk over some wires that are called the CAN bus. So cars usually have ports under the steering wheel that expose the CAN wires for mechanics to use. And that's exactly how I connect my system to the car. I spliced this automotive cable and attached it to a CAN to USB converter, which lets me send and receive data from my computer to the CAN bus. After some trial and error, I eventually figured it out how to decode the car's speed from the speedometer and integrated that into Cruisin's software. The final result is this ADAS capable of detecting obstacles, mapping my drive, and displaying any data I want from the CAN bus. So this next clip is basically a highlight reel of a drive that I had in downtown Kitchener using the Cruisin system. So you can see in the top left we have the visual odometry that I was talking about. And as you can also see that it detects vehicles and pedestrians when they're close enough to the car, and it draws a little bounding box around them. And finally, in the bottom left, it displays the speed and also any other telemetry data that I might want in the bottom left in text.